Hey guys, this is Garrett Wong, also known as Ensign Harry Kim from Star Trek Voyager, and you're watching Astronomy Live.
T minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Stop.
Hi folks, welcome to Astronomy Live. So I'm going to be doing a bit of streaming today, just showing the development of my latest program, UFO Tracker. This is the Python-based implementation of my rocket tracking software, and I'm going to be working on it here, applying it to the LX200 Classic. I had already developed a basic version which works reasonably well with the Celestron NextStar mount, which I used during the SpaceX DM-1 launch, but I haven't actually applied it to the LX200 Classic yet, so that's what I'm going to be doing here. Also, wanted to make a brief update about my YouTube comment monitoring program. You can see the Discord here. So this is a Discord channel I've set up to monitor deleted comments from various channels, and I recently started monitoring my own channel because it wouldn't be fair not to, right? So I noticed this morning that there was a comment deleted overnight on my channel, which I did not delete. This isn't terribly surprising. I knew this was going to happen at some point because people can delete their own comments, and I have no control over that, obviously. I checked, and this was definitely not deleted by a moderator. That would actually show up in my held comments queue. I'd be able to see if a moderator had deleted it from my channel, and that is not the case here. This is somebody who either deleted their own comment or maybe YouTube deleted it themselves. I don't know if that's a thing that happens, but I know YouTube has gotten more concerned recently with comments made by users who were engaging in some nefarious activities on other channels, and as a result, a couple things have changed recently with YouTube. One is that certain channels featuring children where some very disgusting comments were being made, those channels have lost their comment sections in some cases. Not necessarily because the videos themselves were violating any rules or doing anything negative, but that the comments in those channels on those videos were disgusting. At least some of them were. And so in order to protect itself, in order to protect the kids involved, YouTube has made the decision to remove the comment sections from some of those channels. So that's one step they've taken. Another step they've taken is actually to start judging the monetization status of various channels in part based on the comments on those channels. So just because your channel might meet all monetization standards, might meet YouTube's content guidelines, if you have a comment section that you don't moderate and there are, negative comments there that would impact the monetization eligibility, they will judge you for that. So for example, again, coming back to videos featuring children, if you have comments that are bordering on exploitation of those children, and you're not monitoring that and you're not dealing with that, they can potentially demonetize your entire channel for that. So I want to make the point clear that my comment monitoring program is not a position statement by me saying that there's never a case where you should delete a comment. I'm not trying to make that argument. I'm simply providing proof of what got deleted, and in some cases you can go through these various channels that delete a lot of comments, and you can see that oftentimes the comments are being deleted not because they are negative or filled with foul language or threaten the monetization status of the channel on which they're posted, but oftentimes simply because they disagree with the channel on which they are posted, and you'll see a lot of those comments get deleted. There are very few comments deleted off my channel since I started monitoring it earlier this week. I tried to actually set up the monitoring before that, but I goofed it up. I made a mistake in assigning the playlist ID. How it works with this is it monitors a playlist that contains all videos posted by each channel, and I accidentally had an I switched for an L in that ID on my channel, so it wasn't actually monitoring for the first week that I thought it was. And then I noticed one comment got deleted by the person who posted it, and it didn't show up, and I thought, that's weird. So I double-checked and realized it wasn't actually recording the comments on my channel. So I fixed it and did a test comment where I posted a comment myself and deleted it, and there it is. So it's working now. And then, as I said, I woke up this morning and noticed overnight there was another comment deleted, which I did not delete, and was not deleted by any mod. This is a comment that this person has either deleted themselves or, and I don't know if this happens, it's possible maybe, if their channel gets deleted by YouTube and YouTube is deleting their channel because of comments they were making on other channels, I would suspect it's possible for YouTube to simply wipe out all comments ever made by that channel. I don't know that that's happened in this case, but I'm just speculating that could be a reason why comments sometimes go missing if that comment came from a channel that was banned for comment violations. And my understanding, and again, this is somewhat speculative based on things I've read on Reddit and other places, looking at how YouTube handles moderation. There's a strike system in place for community guidelines violations if it's in the form of an uploaded video. So if I violated YouTube's guidelines in this video, I could earn a strike for that. And in fact, they've even implemented a new system where you're given a warning before you're actually given a strike. A strike will actually impact what you can do with the channel. For example, I wouldn't be able to live stream right now if I had a community guidelines strike. That's my understanding. The warning system is to give you sort of a heads up that you're crossing the line, so in hopes that you don't cross it again. But all of these strikes and this warning system apparently doesn't apply to comments. And they can simply wipe out your entire account with no warning given if they see you making serious violations of their guidelines in comments. For example, a very common violation from what I've seen is people will say, my account got deleted, and it turns out what they did is they had promoted their channel on other people's channels in the comments. They'll say, hey, come like my channel, come subscribe to my channel on, PewDiePie's channel or whatever, and that will get them banned with no warning necessarily. And that's because the warning and strike system doesn't apply to comments, from what I've heard. So in that case, if they were eliminated from YouTube for a comment violation, I can see a situation where it would be likely for YouTube not wanting to go through every single one of their previous comments and figure out which ones did or didn't violate their policies. If they see a recurring behavior of policy violations, they may simply say, okay, nuke all this person's comments they've ever made. And so that's one possible reason. But nevertheless, it is entirely possible for a user to delete their own comments. And so that may have happened here. It definitely wasn't me. So I just want to get that out there. I didn't delete this comment. I don't delete comments usually unless it's, something really bad. And I do have filters set up on my channel for profanity, and I generally don't allow those comments. Sometimes they'll get through the filter, but if they're stuck in the filter, I usually don't release them, whether or not they're for me or against me. Oftentimes they're against me, but oftentimes they're also in my favor. They'll say, this video is really great, and they'll use, some expletives in there, and I don't generally allow those. And now I have a good reason not to, because another programming update here. My channel is finally approved for monetization on YouTube. So I'm hoping that the monetization that comes from YouTube can help defray some of the costs of doing what I do. This equipment that I'm using, I've got a big telescope here hooked up to my computer right now. I'm going to be programming that here shortly. But, this stuff doesn't come for free. In fact, I bought a whole telescope just for the purpose of writing some of these programs. The Nexstar telescope that I have it because I wanted to be able to test my software's ASCOM functionality. It just wasn't practical to sort of beta test this software with other users. There's just so many issues that need to be worked through when developing software like this that I need to be able to rapidly prototype it and just test various iterations of the program until it works. And that's a very frustrating process to try to do for both ends of the equation when you're trying to do it with someone else on the other end who might have a piece of equipment that I don't have, like an AutoStar telescope or an ASCOM compatible telescope. Trying to get that working with my software, it's very difficult because oftentimes there's not just one issue that's potentially holding up the program, it's multiple issues, and the easiest way to deal with it, of course, is to simply just rapidly prototype through it. And so it's just not, as I found, it's not easy and it's not practical to really expect others to do that process for me. So that's why I acquired that telescope. So, hopefully the monetization from these videos can help defray some of those costs. I apologize that you guys are going to have to see ads on my videos now, regardless of whether I'm using copyrighted music or not, which now I'm not using copyrighted music. I do use Stellar Drone music that's with permission from Stellar Drone himself, so I'm okay to use that, but yeah, you'll see ads on those videos anyway now. So is one of those UFOs the Benatar? So yeah, the UFO Tracker, let me go to that now. So this is the program and sort of where I left off last night. I've started working on this to be able to make it compatible with the LX200. This is sort of a cousin of the satellite tracker that I previously developed. So Sat Tracker, it's available on GitHub, and you can download the source code now. It allows you to track low Earth orbiting satellites and do video-based guidance on those satellites to be able to keep them centered at very high magnifications and see things like the space station close up and in high levels of detail. And it's very good at that. But it isn't capable of allowing you to track objects de novo without knowing the trajectory of the object ahead of time. You have to have an orbit that you've loaded into the program, orbital elements that you've loaded into the program to enable it to track that object. It'll start tracking based on the orbital elements, and then when you click on the object in the video window, it will switch to basically video assisted guidance. It's still tracking, technically it's still tracking based on the orbital elements, but it's correcting the tracking based on what it actually sees in the camera. So that's how you can keep it centered at a very high magnification. But it doesn't allow you to track objects willy-nilly. If I want to track a rocket launch, I don't necessarily know the exact trajectory that rocket launch is going to take from whatever position I happen to be situated at watching that launch. In fact, that position can change on the day of the launch with very little warning, depending on the traffic situation, the parking situation, all of that. So I need a program that is able to track things like rocket launches without having to know ahead of time what the trajectory is going to be relative to the telescope. And so that's what this program's all about. And the way this works is the initial tracking will be based on joystick inputs. So I'm using Pygame. So this is a new dependency that wasn't present in Sat Tracker. I'm using import Pygame here. This allows me to access all the joysticks connected to the computer. And right now the program just assumes that you're going to use the first joystick connected to the computer. I'm not exactly sure what will happen if you try to hook up multiple joysticks to the computer. It's going to pull joystick 0, which is the first joystick on the computer, and get the access rates for the x-axis, the y-axis, and the throttle axis of the joystick, and use that to control the telescope. So you can steer the telescope around with the joystick initially. And then the next step I have to implement is the video-based tracking, where if you click on the object in the video window, it will start tracking it based on what it actually sees, the visual input on that. So, yeah, it's a great deal of work, and the Benatar. I knew that name sounded familiar. So that's from what we call it, Avengers or Guardians of the Galaxy or something. One of those Marvel movies, yeah. So, yeah, you could use it to track, UFO spacecraft. If you see something in the sky and you can't identify it, you can track it with this program. The other real big feature I have yet to even start implementing, but I kind of have a template for it, is I want it to be able to also log the position the telescope is pointed at over multiple points in time. So over some cadence, like once a second or whatever. And I might even make that user selectable if I'm really clever. Have it log the position the telescope is pointed at and or the position of the object as seen in the video window. And log that in IOD standardized format. So IOD format is used by amateur astronomers to determine the orbits of satellites that aren't necessarily publicly available. amateur astronomers will very often track classified satellites like the X-37B, the secret space shuttle that the Air Force, I believe they still have it up there even now. It's been on one heck of a long mission. And amateurs are tracking that thing and keeping up with it pretty regularly. The way they normally do this is they'll take a sensitive camera, point it at the stars where they expect the satellite to pass through the field of view, and then simply record it passing through the field of view. They might know roughly where it's going to be, what the orbital plane is, and roughly when it'll show up, but if it hasn't been observed in a few days to a couple weeks, it might be a little off from where it's expected to be, especially something like the X-37, which, because it's only up there for a year or two at a time, it is free to use its fuel to maneuver around, and it maneuvers around a good bit. So it can change positions and change orbits on a fairly short notice. And so there may be a great deal of uncertainty of exactly when it will show up. And so they watch for them, record them passing through the camera, and then they'll use the stars as reference points to determine the coordinates. So I've previously released software for determining the orbits of satellites based on images from cameras like that, where you've got a satellite passing through the field of view, and you click on the position of the satellite in the various images to log the coordinates based on astrometry. And that is probably the most accurate way to do it. That's very high accuracy, because you know where the stars are, you know the exact coordinates of all the pixels in the image. In this case, this is going to be more casual in a way, I guess, but also potentially faster, because the telescope can slew to multiple satellites in a night, or if you see something in the telescope, you can track it actively and track it over across the sky pretty quickly and automatically, and then log the coordinates. It won't be quite as accurate because it will be dependent on the pointing accuracy of the telescope and the accuracy of the telescope's encoders that tell the telescope where it's pointed. That's not going to be quite as high in accuracy as proper astrometry, but for a quick first pass of something that you don't know what it is, it's unidentified, it should help you get an approximate orbit. So that's another feature I intend to implement here. So last night I focused a lot on trying to get things running with just the joystick-based tracking on this software. So I'm going to go ahead and fire up the program. So here it is, and go ahead and start the camera. Actually, I need to plug in the camera. Let me do that real quick. Okay, so I've got a little video camera positioned to piggyback on the telescope. This provides guidance for tracking objects. So hopefully it's all showing up okay. Let me see how it looks. Yeah, it is showing up on the stream. I didn't know if OBS would be able to capture it properly. It looks like it is. So it's a little dark in here. Let me open up the blinds, see if I can get some more sunlight coming in here. It's a little better. Also helps to open up the iris on the camera. Okay, that's reasonable. Now, let's see. I should still hopefully be connected on COM port 5. Let's check that. Yep, should be connected on COM port 5, so connect scope. Connecting to scope. And actually, I should change that to say connected to scope past tense, because it is connected now. Okay, so let's show... Will this work? I think this will work. Let's see if this works. So I'm going to test the camera calibration system. Hopefully it's still going to work. So I've clicked on a portion of the sign here using feature-based tracking, and it's now tracking that portion of the sign, and hopefully this will work. Yep, it's working. It's not moving the telescope terribly fast, but that's by design, because it doesn't know a priori how zoomed in this guidance camera is. You could have this on actually a piggyback telescope and do this with a like a refractor, even a wide field refractor would be a lot more zoomed in than this, and so you don't want to move the telescope too fast while it's calibrating, because it'll zip right out of the field of view before the program has a chance to keep up. But this camera is very zoomed out. It's a very wide angle security camera with a standard security camera lens, 5mm focal length, so you got to be patient. It'll take a while before it finishes calibrating. It's going to move the green box a certain distance through the image, and then when it reaches a certain distance in the image, it will look at how far the telescope has moved. Okay, and it just did that, and it says, okay, image scale 0.07 degrees per pixel, so it's figured out the approximate image scale in theory. That seems like it's pretty low. I wonder if the telescope was reporting its position accurately, because I do have it set to land mode right now. Actually, that's a good point. I haven't really tested that before. Let me start joystick tracking here. Oh, buttons has no object, no attribute set. I've got the right version of the program loaded, right? Huh. So it's gone to threading. Oh, I see. It's because I see what it is there. Okay, let me disconnect the scope stop camera and reset the program. That's my fault, because I haven't implemented video-based tracking yet, and because I still had an object selected by video-based tracking, it assumed that I was trying to track based on video input. I haven't implemented that feature yet. That's what I'm going to be working on today. So it gave me an error there. So I got to do this again. Okay, first of all, let's do feature-based tracking, track the sign, and do camera calibration. So we'll do this again. And then before I start joystick-based tracking, I have to turn off video-based tracking, so that green box has to go away. And with this program, like Sat Tracker, it's very simple. You just simply right-click to undo video-based tracking. I don't know if you guys can hear it. The telescope's purring away in the background as it slowly moves up and watches how much the object it's tracking is moving. And that's kind of how it figures out the width of the field of view and the image scale, which is necessary when you are doing video-based tracking to know that number. Okay, so it gave us a very similar number here. That's a good sign. I do want to zoom in and try it again and make sure the image scale is working properly. Actually, I'm going to move the whole telescope a bit here with the joystick. Okay, joystick-based tracking is working. I'm zoomed in pretty far here, so I should get a pretty small image scale. You can also change the size of the tracking box with the mouse wheel. So feature-based tracking, let's see if we can track that, and then do it again. Okay, 0.01 degrees per pixel versus, what was it before? I think it was 0.07. Yeah, 0.07. So yeah, about 7 times is zoomed in. That's about right, probably. This is a 5 to 50 millimeters, so basically you can, if my math is right in my head, you can get 10 times as much zoom, maximum. And I haven't zoomed in quite all the way, but yeah, that seems reasonable. And I think I'm gonna try it one more time. I think with this lens, the maximum zoom is supposed to be 0.008, something like that, degrees per pixel. Okay, this is now maximum magnification of this lens. So let's see if my memory's right. So notice, when I start tracking an object below the center of the view, you can see where the center of the view is on that red box. It knows to actually move the telescope in the opposite direction to bring the object higher in the view, to try to minimize the chance it could go out of the view during the calibration process. So yeah, image scale 0.008, yada yada yada. Yeah, that's correct. Okay, so image calibration, image scale calibration is working correctly on this version of the program, so that's good. Alright, so how's everything working here? Stream's still good? Looks like it. Yes, and there will be a $5 charge for whining, so no whining. Also, let me check reversing the axes on the joystick. Yeah, that's reversed x-axis. Reverse the y-axis. Yeah, that's all working. That's good. That's useful in some cases. That was actually very useful to me during the SpaceX Demonstration 1 mission launch, where I had the camera looking through the telescope that I was using to track using with the joystick. That was with the NexStar telescope. So I had the NexStar telescope at the Saturn V Center, and I was going to track it based on the Canon camera looking through the telescope and taking the video output, throwing that on a monitor, and I was going to track it with the joystick based on that. However, because it was looking through the NexStar telescope, the NexStar reversed the image horizontally, and that led to a conundrum there. If I was going to track it with the joystick, it was going to feel like my directions were reversed during the launch, So fortunately I had already implemented this feature where I could just click a checkbox and reverse the x-axis on the joystick, and also I'm able to reverse the image orientation. So if you've got a flipped image due to your telescope, if you're looking through like a refractor, if you've got your guide camera looking through a refractor or something and it's reorienting the image, whether it's vertically flipping it or horizontally flipping it, or you could do both, you can fix that very quickly with the image orientation setting. And you can also reverse the X and Y axis controls on the joystick. And you want to do this especially if you're going to be doing optical based tracking. The program doesn't know. It's not going to check the orientation of the image. It's just going to assume that the image orientation is normal. So before you start tracking, you want to make sure you've made the image orientation normal with the image orientation setting. Alright, that's all good there. So I'm going to go ahead and disconnect the scopes, stop the camera, and file exit and save the configuration. Very important there, if you want to save your camera calibration. Actually, did I recalibrate? Maybe I didn't. I should probably recalibrate. If you want to save your camera calibration, it will do that, but only if you exit by clicking File, Exit and Save Configuration. If you don't want to save your latest settings, if you messed something up or you just don't want to save the current settings, if you exit with the little X box up here, it will not save the settings. It'll simply exit the program without saving. Probably not the most elegant way to implement that, but it's functional for now. Connect the scope, and let's see here. Let's go ahead and, I don't know, pick something. And then camera calibration. So before I start implementing video-based tracking, I need to make sure that the program is going to know what the actual image scale is in degrees per pixel, because it's going to try to calculate the coordinates of whatever object it's tracking in the view, and to know that it needs to know the image scale. Okay, I'm going to do that one more time just to confirm. Very good. Okay. Alright, so I'm going to disconnect the scope, stop the camera. You want to do those before you close the program too, because if you leave the connection open to the telescope, it could really mess things up. You may even have to reset the telescope to get the connection to work after that. So you want to make sure to disconnect things and stop the camera before you exit the program. Again, these are things that in a later version I should take the time to make sure that the program checks that and does it for you if you haven't done it yourself, but I haven't done that yet. Alright, so right now this stuff here is all just for out as. I haven't implemented all of this in the EQ setting or equatorial aligned setting yet. It's pretty much the same code, just sort of replaced. Instead of altitude and azimuth, you're working with right ascension declination. But as far as joystick-based tracking goes, there's not much different there. I'll work on that later. The main thing I want to do today is try to implement video-based tracking, the fun stuff, and for me, the important stuff before the next Falcon Heavy launch. So the way this program works is it goes through a series of if checks when you start tracking. If the tracking setting is on LX200 and if it's on ALTAZ, it does this, and that's if object follow is false. Object follow becomes true when you begin tracking something optically in the video window. So if object follow is true, it does all this for ASCOM. This is something I'm still working on. It's not really ready yet. This is assuming you're in ALTAZ. So with an ASCOM-based telescope like a Celestron Nexstar, you can use the ASCOM setting and track theoretically track the object on video with this. Now, some telescopes have ASCOM drivers that will not work with this program, and it will do a check for you when you first connect to the telescope based on ASCOM. It will check and make sure that that ASCOM driver implements the move axis function, which is a command that it's going to send if you're on ASCOM. And let's see. So here it is, move axis. It's going to send this command to actually move the telescope. If your ASCOM driver doesn't implement that method, you can't use the ASCOM setting on this program. It just won't work. And for example, the LX200 I have here doesn't implement the move axis method. In fact, even the newer LX200s, as far as I know, do not implement that method, which is silly because they do have functionality that could be translated into a move axis method. Move axis basically allows you to manually set the drive rates. You're directly telling the telescope, I want you to turn this many degrees per second in X, this many degrees per second in Y. So it makes it pretty simple to implement a program like this, where you're directly tracking a moving object that you see on video. That's very nice and convenient, and newer LX200s, AutoStar-based LX200s, do have a function that should allow for that, where you can directly set the drive rates, but for some reason no one has implemented that in an ASCOM driver for them, so you can't use ASCOM. And so you have to use the other method, which I've developed, and I'm going to show you guys what that's like here, because I'm going to be implementing it here in the Python version of the program. I did this before in Visual Basic with Teletrack, and it works reasonably well. It's a bit of a workaround around that limitation of not being able to directly set drive rates, but I can't guarantee the implementation works with the newer LX200s. It works with the LX200 Classic that I have. This is the pre-AutoStar, pre-GPS LX200 with the old Magellan computer. And in theory, it speaks the same language as newer LX200s. It's just the newer ones have an expanded vocabulary, which allows them to directly set drive rates, but not through ASCOM, which is, again, just silly. So as far as implementing this for newer LX200s, I kind of have two ways I can go about that, because I can't guarantee the solution I have for the LX200 Classic will really work with the LX200 AutoStars. So I can either speak directly to their expanded vocabulary in order to directly set drive rates, very similar to what I do with ASCOM, and that's probably what I'm going to have to do. I haven't done that yet, but I'll get there eventually. The problem, again, is I don't have a newer LX200 to test it on, personally. So that's an issue. But where's my mouse? Oh, here it is. The other option would be to basically develop my own driver for the LX200, the newer LX200s, an ASCOM driver that implements their ability to directly set drive rates as a move axis method. Theoretically, I could just write a whole new driver, I guess. Ugh, that's painful. That's the longer road there, but it would allow them to just use the ASCOM setting. I don't think I'm going to do that. That would require a lot more effort, and probably it would probably require me to learn more about C or C++ or something like that. I'm guessing I couldn't do that through Python. Never written a driver before, and don't intend to start now, so we'll do it the other way. We'll just implement it directly in the program, speaking directly to the LX200 AutoStars at some point. Okay, so this code here is what it will execute or try to execute if you are tracking an object on video when you have the start joystick tracking enabled. So kind of the way it's going to work is very similar to how the old Teletrack program worked in Visual Basic, though the interface here is a lot nicer, for sure. But if you just click, even if I'm connected to the telescope right now, if I just click on something, it'll track it on video. If this object were moving, it would track it with the green box, but it's not going to try to chase after it with the telescope. Like right now, you can see nothing's happening. The telescope isn't moving, it's not doing anything. And if I were to click Start Joystick Tracking right now, it would cause an error, because what I've got in there right now is leftover code from Sat Tracker, which is non-functional, because this isn't Sat Tracker. I'm not tracking a satellite based on orbital elements. There's no provision to load orbital elements in this program. In fact, even the title up here still says Sat Tracker. That's bad. I need to change that. This is UFO Tracker. This is not Sat Tracker. But a lot of the base functionality is the same. That's why I just brought the code over, and I've been modifying it into UFO Tracker, because at a basic level, it's very similar. It's just that we're not loading orbital elements here. We're just tracking with joystick and video-based tracking. So, again, it's not going to try to move the telescope right now. It's not going to try to do anything. And if I click Start Joystick Tracking right now, it's still not going to do anything. Out rate, as rate are reporting 0 because I've got the throttle all the way down. And what that will do, I've written it in the program, so that if the throttle is at 0 or close to 0, it will issue a stop command to the telescope to stop slewing. So if I start slewing with the telescope, let me engage joystick tracking. In theory, yep, as soon as I throttle down all the way, it immediately stops the telescope in its tracks. So throttle down inhibits motion, and I'm kind of trying to decide right now if I want it to inhibit motion even when video tracking is going on, if you've got the throttle all the way down. That's how I did it under Teletrack. I guess I'll do it the same way here, probably. There's pros and cons to that. Well, pro is it's easy to stop the telescope if you don't like the direction it's going. If it's getting too close to the sun or something like that, and you don't want it to damage the telescope, you can throttle all the way down and stop it in its tracks without having to disengage tracking by right-click. You can just have your hand on the throttle and very quickly stop it. I kind of like that, but the con is if you've accidentally got the throttle set to 0 and you try to start tracking something and you engage Start Joystick Tracking, it's not going to move. And you may be left wondering why for a moment before you remember, oh, I've got the throttle all the way down. So there's pros and cons to it, but we could start with that. Disconnect scope, stop camera, and file access, save settings. Okay, so like I said, right now the way this is set up to work, it's got leftover code from Sat Tracker. In fact, I probably should just change the title of the program. Where is that located? I've forgotten where that's even located in the program's code. Let's just do a find Sat Tracker title. Here we go. This is no longer Sat Tracker. This is now UFO Tracker. There we go. UFO Tracker. Hooray. With the default Tkinter icon. Because who cares? Alright. Now let's go back to... Okay, this is Alex 200 out has. This should be... Yeah, this is under if object follow is true, so that's if we've selected something by video, this is what it's going to do. So, right now, it starts off and it tries to get the satellite azimuth in degrees and add 180. Right. The reason it adds 180 degrees, flips it around 180 degrees, is that the LX200 is a little weird. The convention for its azimuth readings are such that 0 degrees is not due north, it's actually 0 degrees due south. So you have to add 180 degrees to any calculation you do that would yield normal azimuth values for a satellite. Say it's coming up 90 degrees, or it would normally be setting 90 degrees in the east. To this telescope, that would actually be 270, not 90, because it's backwards. It's just weird. So it does that. It makes sure that it doesn't go above 360, all that fun stuff. So basically it's just setting up and formatting the azimuth, and then it puts it into radians, because that's what Python's going to do most of its calculations as, with radians. But I don't always have it standardized, it seems. converting to degrees here for reasons. I'm sure I had reasons for doing that. Okay, so this is kind of useful. Self-D now is greater than self-D last. This is important. What this is, with my terrible naming conventions here, because this doesn't look like it means anything, this is confirming that the current video frame that it's going to look at is newer than the previous video frame. And I also remembered there was something else I wanted to do back up here under joystick tracking. I didn't do this last night, but as I went to bed, it occurred to me that it seemed like when I'm getting so what it does is basically it gets the current altitude and azimuth from the telescope's encoders, and it adds to that the altitude and azimuth rate based on the joystick input. It seems like it was getting the same altitude repeatedly, like every 2 samples would be the same or something like that. Probably because the program's running faster than the telescope's able to run, especially on this computer. So I probably want to put a time sleep in here for a brief period, like 1,000th of a second or something, to give the telescope a time to catch up to what the program's doing. We'll do 100th of a second and see how that goes. I just want to check something here because it seems like there's a bit of an oscillation going on with joystick tracking right now, and I suspect it might be because the program is operating faster than the telescope can keep up. I still hear it. Okay, and if you look real carefully here, stop joystick tracking, go up. So you see here, it reports the same azimuth for like 3 samples, and then it reports a new azimuth for 3 samples. So the program's definitely operating faster than the telescope can keep up. That may or may not be a big deal. That may not really matter in the grand scheme of things. I don't know. But let me try to sleep the program for longer. Let's do 1/10 of a second. Really give the telescope plenty of time to catch up to what the program's doing. But at some point, because the way this works, I'm not directly setting drive rates, am I? I'm just telling the telescope this huge slew of go-to commands in a very quick succession. And that's producing the illusion that I'm telling the telescope how fast to move, which gives me smooth control over the speed with joystick deflection and joystick throttle. But it's sort of an illusion, because I can't directly tell this telescope how fast to turn the drives. It's just a limitation of the command set of this joystick. Or, it's not this joystick, the telescope. So here, yeah, it's reporting a unique value every time now as it's moving, pretty much. Maybe once in a while it's not, but it's having a lot easier of a time keeping up. But you hear that beep, 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 sort of the staccato beeping. So it's not receiving as constant a string of go-to commands. And actually, that does seem to make the tracking a little choppier. So I think, given the choice, maybe we could try to find a happy medium here. Let's try 200ths of a second. A little fine-tuning here, just by trial and error. Start joystick tracking. I don't think it really matters. I mean, it seems to me like it's not a big deal that the program's running. I'd rather the program run faster than the telescope can keep up than the other way around, because it seems like it feels to me like the tracking's a little choppier when I've got the sleep setting here set relatively high. But I do want to add a sleep step in there to give everything a chance to sort of catch up a bit. The thing I found, and I'm not a, full disclosure here, I'm not a professional programmer, right? I'm entirely self-taught when it comes to programming, in Python in particular. And the extent of my formal programming training is a single class in high school many, many years ago. So, totally not a professional programmer here. You should probably go check out CentDex or some other channel that really knows what they're talking about if you want lessons on how to program. But in just goofing around on my own, I found that with slower computers, you run into a big problem if you don't have a sleep step set up in a constant loop like this, where the computer can't keep up with what the program's asking it to do, basically, and the whole thing grinds to a halt almost. It's terrible. There's no time left for the CPU to do anything else than what you've told it to do in the loop. So you want to have some sort of catch in there, some short sleep period where other tasks have a chance to catch up, even if you're doing multi-threading and that kind of thing, and which I am in this program. And that's one of the reasons why later on, when we get to programming the video-based tracking, it has to check, and this is probably not the most elegant way to do it, but it has to check whether self-denow is greater than self-delast, because in a separate thread, it's doing the capture of the images from the video camera. And so those two processes are not synced up. And I know there's probably a better way to do syncing of those processes, but the simple way I found is to simply keep a date-time variable that updates every time it gets a new video frame from the camera. And so that's self-denow. And then it remembers what the previous frame was under self-delast. And so if dnow is greater than delast, then it goes ahead and it says, okay, I've got a new video frame. I'm going to process that now under all this stuff. So, and then when it gets done with that, self-delast will equal self-dnow. So, let's see here. Let's come back up here where I had this time sleep. It's under ASCOM. Okay, 100th of a second. I think that's fine. The other thing I wanted to do here real quick is if the telescope's issuing the stop command, I don't want it to print out. I don't want it to keep printing out the text box messages. These text box messages tell it, that's what puts it in that text box below where you see what the out rates, as rates, all that stuff are. Also, there needs to be a bit more spacing here, formatting that. Okay, this should only print out, hopefully, if it's currently moving. So let's put that under there. So now if the throttle is less than 0.001, so in other words basically 0 or very close to it, like not all throttles, including mine, are calibrated entirely properly, so they'll still report a very, very small value even when all the way down. So you don't want it to have to be equals to 0 exactly, but if you're very close to 0, consider it 0, and then write this Q hashtag is the stop slew command for the telescope. So it won't try to track. In fact, it'll stop the telescope wherever it's pointed. So let's test that now. There we go. Okay, so that works good. So now we're not flooding the text box with redundant commands, redundant messages while it's stopped. And so it's reporting the commanded azimuth, commanded altitude, out rate, and as rate as commanded by the joystick. Okay. So stopping that, let's go down here and now work on video-based tracking. So here we go. So we do need this check in here. We're going to need to leave that in place because we need to know if the latest video frame is newer than the old video frame. Another question is, do I want... I think I do. So I kind of want the as and out rates to carry over from joystick tracking in that transition period where you've first clicked on an object that's moving, especially if it's moving quickly. You don't want the telescope to stop while it tries to figure out how quickly that object was moving according to the video. You want it to basically remember what it was commanded to do under the joystick, and that should be available. That should be available by out rate and as rate. So out rate, as rate is there. Out rate, as rate is available here. And I ought to know the answer to this, but I'm not entirely sure if... Yeah, it should remember these variables because we're not transitioning here into a new event. We're not transitioning into a new method. This is all under def track. So I don't think it will forget that. Now it does actually zero that out. Why did I do that? Oh, that's the out correct, as correct. Okay, those were different variables. I was setting those up under here. This is for ASCOM, but I think it will remember the as rate, out rate variables, and I use those under both ASCOM and LX200 based tracking. And as for ASCOM video based tracking, that's sort of implemented. It's ugly at the moment. It doesn't work great, to be honest. I'm trying to figure out how to implement what do you call it, Kalman filtering to do the tracking. In theory, that should make the tracking smoother, and it's based on some complicated math, looking at, I think, covariance matrices or something like that. It's complicated, and I don't fully have my mind wrapped around it yet myself. It works, air quotes, big air quotes. It's sort of, right now, it sort of dances around the object. It tries to follow it and it sort of spirals in towards it, but it's not great. Now, if I just do a straight up tracking without the Kalman filter, I can actually make it work better, but I kind of have to fudge it a bit. I kind of have to force some multipliers into things to try to make it keep up. It's not great, so I'd kind of like to have it implemented as Kalman based filter based tracking, and that would definitely be the more elegant solution, but I don't really have it implemented correctly yet, I don't think. So I'm still tuning all that and trying to get all that working. Like I said, it sort of works, but it's not great. So still working on that. But as for the LX200, I'm going to try to do this kind of the way I did it originally, which isn't really Kalman based filtering. It's a whole workaround anyway. It's basically creating virtual points the telescope is trying to point to keep up with the object, and then it looks at how far it's trailing behind, and then it catches up. It issues a corrective factor to catch up. And I probably should pre-populate those variables up here where it does the joystick-based tracking. So just reset these variables to 0 so that if you have disengaged video-based tracking, it will reset these to 0, because it's going to go back into this method if object follow is false. All correct as correct. And we come down here. I'm just checking the chat, see if there's any questions. I need to keep that window more prominent so I can follow the chat. Alright, so yeah, it's setting up the azimuth values for satellite because it thinks it's tracking a satellite. It checks whether the current video frame is newer than the previous video frame, and then it gets telescope's altitude. So this is issued twice. It gets the telescope's altitude twice because usually the first one, not the most elegant solution, you'll hear that said a lot here, but there's a lot of junk in the buffer, in the serial buffer, where it's the telescope's been trying to tell the computer, hey, I've gone to the coordinates you told me to go to. It issues basically a, I'm okay, I'm okay, I'm okay, and it just fills up the buffer. And so the first command to receive data from the telescope, it comes out as gibberish because it's filled with those I'm okay statements. And so I clear out the buffer by simply getting altitude twice. The first one I just basically discard, and then it populates it correctly the second time, issued immediately thereafter. It works. It's not great, but it works. Then it gets azimuth, which is still okay because it's currently receiving the data of coordinates, not the I'm okay stuff. This is all very, very quickly done. And so then it gets current azimuth. And so now it's calculating object vertical, object horizontal, object angle, all this stuff, object distance. This is all based on what it sees in the video. This is the object it's tracking. This part can stay. This is good. We need this information. That's going to be true whether you're tracking a satellite or tracking some other object. It's getting the current position of the object in the video. I need a crab cleaner. Yeah, I do. I just need a better implementation of the communications protocol, really, for the LX200. Not so much for ASCOM. ASCOM is fine, but for the LX200 Classic, it would be ideal to have some other process running in the background that's constantly receiving those I'm okay signals, and maybe even doing something if it sees that it's not okay, but I've never had that really happen before, so it's not, those signals aren't important for my program. They just sort of get in the way, which is why I've implemented the quick, easy, dirty solution of just saying, okay, let's just clean it out with one receive command and then do a proper receive command. But all this stuff up here, this is pretty much garbage. So I'm going to delete that. Really, we don't need... too much there. So if we have a situation where it comes through on its pass and it sees, okay, the frame is not new, it's an old frame, it's going to get frames at about 30 frames per second, thereabouts. You want to possibly be issuing commands more rapidly than that, so it will track based on last known velocity vector, and we're going to get to that. That'll be fun. But at the start here, I don't think we really need anything. We just need to check and see if the video frame is new. And if it is, we need to figure out what the object's position is based on the new video frame. That's what all this is doing here. So you can see how it's using image scale, so that's determined by the image calibration stuff, the camera calibration stuff. And then we do a try on this. So yeah, this is figuring out the current altitude and the difference in azimuth from the pointing azimuth of the telescope based on the angles we calculated up here. Alt diff, as diff, total diff. Okay, now this was a section that I had from my old SatTrack program that, okay, this is if last total diff is less than total diff. So in other words, total diff is greater than last total diff. So if the difference, if the distance to the satellite is increasing, then you increase the, you basically increase the correction factor. So it's going to issue a correction factor to try to keep up with the object. It's basically got to lead the target, because what it's doing is it's not directly controlling where or how fast the drive rates are turning. It's issuing go-to commands. It's telling the telescope, I want you to go to these coordinates. By the time if it simply tells the telescope go to the current coordinates of whatever it's tracking, it's always going to lag behind. And the faster the object moves, the more it's going to lag behind. Because by the time that command's issued, it's already too late. The object's now in a new position. And so you have to issue a correction factor. And I do that sort of empirically here based on it's a constantly changing value that takes the previous value and adds on the current value of the difference. So it says, okay, I see we're a little bit more behind than we were on the previous frame, so I'm going to add this to the correction factor in order to lead the target a little more and catch back up to it. So that's how that works. And then it prints, goes to a print statement, which doesn't really matter if you're running a compiled version, but it shows up in the DOS window. Text box insert, distance from target. Okay. Last total diff. So it remembers the current total diff as the last total diff for the next loop. And then it moves on. Okay, so let me think about this. Is this acceptable in its current form? I think we could start off this way. Right. But what's going to happen... Okay, what's going to happen here, down here, is, okay, we've got... It's basically trying to pull azimuth and altitude values. These are what the altitude and azimuth values of the satellite were predicted to be based on its orbit. And then it's adding these correction factors that are based on what it sees visually in the video. And that produces a final go-to command that is then converted to sexagesimal. That's degrees, minutes, seconds, degrees, minutes, seconds. That goes into the telescope with the right commands, and off we go, slewing towards it. So the big change that needs to happen here is that we don't have a known azimuth and altitude for the object based on an orbit, obviously. We only have what we saw in the video, and we can calculate a velocity vector for that object based on what previously was seen over the previous frame. The big issue there is it's not checking right now if this is the first frame it's ever seen, because then it won't have a known velocity vector. I don't know, maybe we can just work that into it, where it assumes zero velocity at first until it gets an idea of how fast it's moving. Better yet, this is where we bring in, this is where we bring in as rate, out rate. So we have the as rate and out rate from the last joystick command it received. Once we start video-based tracking, we're going to do away with joystick-based tracking. So video-based tracking will override joystick-based tracking. And that may not seem ideal, but it's necessary, especially here, because since I can't set the telescope to move at a predefined rate in the various axes, I can't allow the user to issue joystick commands, because that's going to throw off all the loops, because it's basically going to be tracking in part based on what it sees, but also in part based on how the telescope is responding. That actually becomes part of the guidance loop, because it's looking at how far the telescope's lagging behind, which is basically driven by the PID. It's driven by the telescope's own internal electronics and how it interprets those commands. I don't have a way of knowing how it's interpreting those commands, and I don't need to, as long as I can see how it's interpreting those commands and basically issue correction factors based on how that comes out. So that's why I have to basically inhibit the joystick during video-based tracking. That can't be, because that would be a whole new variable, and that just makes it really complicated and makes it virtually impossible to disentangle what the joystick is doing to the telescope versus what the telescope is doing to the telescope. The telescope's internal electronics are doing to the tracking. Because even the joystick commands themselves are being interpreted by the telescope, and it's producing a certain velocity of the telescope based on a certain amount of joystick deflection. But again, going into it, I don't know how much it's going to actually produce. So when you're doing joystick-based tracking, the human is in the loop. The human is what's looking at the video and evaluating, okay, I need to move the joystick more or less. Without even thinking about it in your mind, you're basically compensating for the telescope's internal way of handling those joystick inputs. The program doesn't have that luxury. I mean, the program, you have to explicitly define all this. So we're going to inhibit the joystick during video-based tracking, but for that first frame where we don't actually know what the velocity vector of the object is, we're going to assume that the velocity vector of the object is whatever the altitude and azimuth rates were from the joystick tracking that we did earlier. So that's out rate, as rate. These are rates that were directly commanded by the joystick. So those are the rates we're going to use on that initial frame. And we're just going to update those based on what the video shows. So it all comes down to this here. So we have a position of the object. So we got out diff, as diff. And we've got object out. We've already calculated object out directly here. So this is object's altitude over the horizon. Any sign of Nibiru as yet? No sign of Nibiru. It's now 2019, so we're going on 7 years since the supposed end date of December 21st, 2012. And we're all still here as far as I know. So yeah, I'm not too anxious about finding Nibiru, but hey, you know, if you think there's spaceships from Nibiru coming to visit Earth, you'll be able to track them with this program, right? So it's all good. Okay, so diff in as, that's difference in azimuth from the telescope's current azimuth. I don't think we have yet calculated the azimuth of the object itself directly. So we'll need to do that. That's easy enough. And the other thing is, as I mentioned before, the telescope's azimuth readings are really weird. They're 180 degrees different from what you'd expect. 0 degrees is due south. 180 degrees is due north to the telescope. But at least for the moment, we don't care about that. We can work in the telescope's internal azimuth and just treat that as the coordinate system we're working in. We don't need to convert to a more standard coordinate system. We don't care at the moment, although later on we will. When we get to the point that we want to log the observations, it's not going to be terribly helpful if they're logged in a coordinate system that confuses everyone. So we'll have to keep that in mind. But that may not get to that today. We'll see. I'll probably work on that separately later. Main thing for now is we need to calculate the actual azimuth, not just the diff in as. So we can do that up here. Current as, that's in radians. Current as is in radians. This is currently in degrees, so we got to make sure that those are standardized. So we'll call this object as. This is going to equal, I think, if my thinking is right, this will equal, we'll do this, what should we do this in, degrees or azimuth, or radians? As correct is going to be as diff. This is all going to be in radians, so we'll do this in radians. I wish I knew why I did this to myself. Why did I convert this to degrees? I don't know. So the current as is in radians already, minus diff in as. And we'll have to change this into math radians. Yeah, there. Okay, so is that right? No, that's not right, is it? Diff in as is going to be. I think it's going to be a plus. I don't know. A little trial and error never hurt anybody. We'll figure it out. If it goes the wrong way, we just reverse that sign. So object out, object as. We now have that. So, in theory, self-rad as. Because rad as, these self means it's going to, I don't know, I shouldn't speak too much to the formalities of Python, but this is basically going to hold this variable over across all the various defined functions, because this is a separate function, self.rad. Oops, what did I do there? I didn't mean to do Control V there. So if I do a quick find on this, so this is a separate function here, and this is going to format from rad as and rad out. It's going to format this into degrees, minutes, seconds, azimuth, degrees, minutes, seconds, altitude, and that will get fed directly into the telescope. So this handles that automatically, so I don't have to explicitly write that out every single time, that whole function there. I can just call that function, and it will automatically calculate those values based on the variables that I'm assigning here. So the altitude and azimuth we want it to go to, in theory, is going to be object as and object out plus these as correct out corrects. But there's more to it than that, because I'd like to have a little bit more I don't know, I don't think that's going to work on its own. It's going to look at how far off it is. Out correct, as correct. So we pre-populated those and we reset those values back up here, right? I'm pretty sure yeah, out correct, as correct. We'll start off as 0. And it's going to look at the difference. It's going to add that difference. I don't know, we can try it and just see if it works. I think I'm going to have to add in functions here to basically take in the rates, like I was talking about before, taking the as rate and the out rate from the joystick, and eventually have that rate updated based on the last known velocity vector. Certainly here, this is not going to work if we lose sight of the object at any point. It has to be able to see the object to do all this. So this may or may not work. I'm going to save this as a new version. And we'll just run it and see what happens. What's the worst that could happen, right? Start the camera, connect the scope. And I don't know, let's just pick something. Let's pick something smaller like that. Ah, okay. So we have an error here, one I wasn't exactly anticipating, but that's good. Just because I want to know. It says buttons object has no attribute dlast, so the dlast variable doesn't exist. Just exit. Okay, so we're missing dlast. Dlast equals self d now. I had commented out here self d last equals self d now. Minus date time delta. Huh. Actually, I'm not sure why that ever existed. Why did I take d now and subtract 0.01 seconds? Self d now. So self d now is getting assigned there when it center is true, otherwise when it's left click. Okay, so when you initially left click it, it assigns the first d now. Right? Oh, I think I see why. This is populating the initial variable. So for the very first frame, you have to basically create a fictitious dlast to say the first frame is new, because you've just clicked. This is for the left click. If you're not setting the center, setting the centers basically tells the program where to put that red box, where to move objects to. It co-aligns the guidance camera with the telescope. So if you're not doing that, then you're setting the object. You're telling it what to track. I don't know why I commented that out, but yeah, you have to create a fictitious dlast to start with, so that that's pre-populated, and to tell it basically, hey, this first image, although it's only the first image, it is a new image. Connect scope. Whoa. Okay. It went somewhere. It thought it was going somewhere. Okay, so you can see it's oscillating back and forth. One interesting thing is it didn't seem to try to move in altitude at all. Okay, so So it didn't try to move in altitude at all during that test, which is kind of interesting. Rad as, rad out, object out. Plus out correct, as correct, out def. So it's giving total distance from target there, but it's not telling me what the I need more feedback on what the out diffs and the as diffs are. Oh, thanks, Fish 9017. So I need feedback on what's actually going on here, not just distance from target. So let's add in a new string. One is correct. So these are the correction factors it's trying to issue to these coordinates. And I also kind of want one down here to tell me what it's actually trying to send the telescope to in azimuth and altitude. Make sure it's, well, it seems like it's not trying to send it anywhere different in altitude, which is kind of weird. I wasn't expecting that. So here we just want we need these to be formatted into strings too. I think it'll generate an error if it's not formatted as a string. Format those as strings. Format this as string. This is going to be math dot degrees self dot brad as out. It's going to be string math dot degrees self dot brad out, and then new line. Okay. This will give me a little more feedback on what's going on. Oop. Invalid syntax. Oh, I didn't close off something properly here. Seems like. Okay, that's closing that off. It's closing what off? It's oh, I didn't close this off properly. There we go. Okay. Nope, I'm still not closing off something properly. 709. Okay, so something here is still not closed off all the way. Oh, I see my problem. Gotta make sure your parentheses are all closed on these statements properly. There we go. Connect scope. Start joystick tracking. Commanded out 675. Oh dear Lord. That's why it's not moving it out. I'm feeding it gibberish. Okay, see? When you get more feedback, you can very quickly figure out what's going on. Pretty quickly figure out. Also, we've got a bit of a weird oscillation, and we're getting gibberish and altitude. Okay, that's fine. We'll figure out what's going on there. But in terms of the oscillation, Commanded as, commanded out. Okay, so let's exit and save. Alright, first of all, let's fix the altitude issue here. So I bet somewhere in this mess I'm converting something to degrees that was already degrees or something like that. I'm definitely way off on calculating the altitude. Object out 90 math degrees, so that's in degrees. Out diff radians. Okay, convert that to radians minus current out, which is in radians. Out correct equals out correct plus out diff. Out diff is in radians, so it's as diff. Okay. Object out. See here, here's an issue, I bet. So this is one issue. This out correct plus out diff. Out diff is in radians, but I'm adding radians onto a value that is supposed to be degrees. And then I'm converting okay, yeah, object as is in radians, object out is in degrees. Okay, this is the problem. This is the problem right here. So this needs to be, this is why you should never ever do it the way I'm doing it here. You should never keep going back and forth between degrees and radians in a program. This causes problems. And we created a problem here. So you need to convert this to radians. Boom. Alright, that's one problem taken care of. I'm pretty sure that's what was causing it not to move in altitude, because I was feeding the poor telescope gibberish. I mean, just altitude values that don't make any sense. 800 degrees and so on and so forth. Oh. Oh, what's going on there? The program got real sluggish for a second. I'm not sure if... Oh. Hi. Okay. The camera's having issues. Could be because I'm plugged into this poor USB hub that's not quite in there all the way. Let's try that again. Let's see. Oh, hi. Yeah, okay. That's not good. Is the stream still working? I guess it is. We're having camera issues here. This USB hub I'm using is terrible quality. I'm using it to connect the microphone, my joystick, and the guidance camera. Try plugging into a different port. Let's see. See if that helps anything. Probably not, because I'm still plugging into the hub, just a different port. Oh, that helped. Okay. Yeah, it's just my USB hub got a little bit wonky there. It's precariously positioned. Alright, connect scope. Start joystick tracking. Come on. Nope. Oh, what's going on there? You know, I bet my poor joystick's now probably goofing up too. Oh, this USB hub is terrible. It's killing me. Yeah, I'm not getting any response from the joystick. Huh. It's either that or it's goofing up the actual USB to serial connection to the telescope. I don't know. That's a possibility. No, actually, the USB to serial is not on the hub. How's my microphone work? Is my microphone still working? Because this is on the hub too. But the joystick is probably wanting a little more power. Okay, I'm going to reconnect things here. We'll put USB to serial on the hub because actually that's probably feeding less data through it than the joystick is. This joystick is also an X52 Pro, so it's got to power lights and LCD screens and all the rest. So it probably didn't like being on the hub, I'm guessing. Alright. Let's try that mess out. Let's see if this works. Connect scope. Failed to connect on COM5. Failed to connect on COM5. Okay. Well, there's two possibilities there. Either the hub really is screwing anything up plugged into it, possible, or I've switched ports. I've switched ports. Now I'm on COM7. Okay, fine. The wonders of variable COM port assignments. COM7. Connect scope. Connected. Start joystick tracking. And nothing. Huh. I'm not getting anything. It's like the program doesn't think the joystick's working. You remember what I was saying before about connecting multiple joysticks? And now I had a clear COM error. Man, I'm running into all kinds of new errors. So I suspect it thinks it's a new joystick because I plugged it into a different port. This is a problem. I'm going to have to fix this later. For now, let's just see if that's really the problem. Where is LX200? Let's set this to joystick 1. So I bet it went up one number because I connected the joystick to a different USB port. I think it thinks it's a unique new joystick and it's assigned a new number to it in Pygame, I bet you. Failed to connect on... Oh, right, COM7. Connect. Failed to connect to scope? Oh, no, it's connected. Okay. Start joystick tracking. Okay, list index out of range, so it doesn't think that's a new joystick. Okay, so it still only sees the one joystick on 0. That's good. Bad news is it doesn't seem to be working. And I'm not sure what to do about that. Oh, I keep forgetting to save my settings. And nothing. Not getting anything from the joystick. Huh. Clear COM failed. The handle is invalid. Serial. Maybe the problem is the serial connection. It's just not getting to the point of listening to the joystick. Maybe. I blame Windows somehow. Yeah, that's probably safe, but actually in this case I think it's hardware. It's this USB hub that I'm plugged into, which is just a piece of garbage. Do I have another USB hub laying around? Yes, I probably do. Alright, hang on a second, guys, here. I'm going to go try to scavenge around for a new USB hub because I think that's the source of my problems at this point. And I just don't want to deal with this anymore, so I'm going to find a new hub. In the meantime, I'll throw on some music for you guys and just chill out for a minute, and I'll be back. Alright, I'm back. So, I basically reconfigured the USB ports on my computer, pulled some stuff out that I'm not using at the moment, and just completely foregoing the use of any USB hub, because that's less reliable. Alright, let's try this again. Alright, camera works. Now, the scope may be on a different COM port again. Let's see. Yep, now it's on COM 8. Connect scope. Start joystick tracking. Hooray! Problem solved. So, at least that problem is taken care of. It was just a USB hub issue. Has no attribute target Y. Really? Huh. That's a new error. Not sure why it happened. Maybe I accidentally erased something in the program? Yeah, I heard about that. P1. 401 closed for Falcon Heavy launch. That's highly disappointing. I'm not super surprised. I figured that was eventually going to happen. But, hey Moo, cynical realist. I'm not terribly surprised that happened, actually. I figured they were eventually going to close down that fun party we were having. I was just hoping it wouldn't be quite this soon. I figured by the time we got to manned launches, actually, that they would start doing that. That's bad news. So, you know, alternatives. I've heard people suggest paying for parking at the parking garage there at the cruise port terminals. I don't know if you can do that. I heard that should be possible on Tuesday. But I've also heard from other people who tried that before that the power lines really get in your way up there. So, you know, I don't know. I mean, is it worth it if you've got a power line going through the launch pad? I guess, maybe. I don't know. The other alternative I'm thinking about is on 528, that final bridge before you get to Port Canaveral. There's those pull-off areas on either side of the bridge, and I think the one that's further west might have a fairly clear shot at the pad and the landing pads. Depends on where you are exactly, I guess, but it seems like some of the videos I saw from the first Falcon Heavy were shot over there, from what I can tell, and looked pretty good, actually. So that's kind of where Red and I are thinking about, but I don't know. We'll see. There's possibilities. So there's the cruise terminal parking garage. There's 528 maybe, and I know they've also said they were gonna they were worried about 528 too, like the median. I guess people were pulling into like the median area. So I think this is all a fallout of the first Falcon Heavy launch, where it was crazy. It was madness on the roads, and not just 528, not just 401, but just all over the place. There were people just pulling their cars off or just stopping in the road to watch this launch, from what I've heard. And so I think they're worried about a repeat of that. And that's why they're doing it now, not in the past year for any of the other launches. They're really worried about Falcon Heavy bringing in that kind of crowd again and just stopping up all the roads. So this is why we can't have nice things. It's tough because I really do want to get close to the landing areas. Banana River Drive, clear LOS to LZ, line of sight to the LZs from Banana River Drive. That's an interesting one. I'll have to look at that later. Because that's what I really do want. Same as you, I want the line of sight to be clear to the landing zone. Huh. Target-wise. Now I gotta figure out. So it had issues with finding target Y. Self.target Y. Set calibration. Target Y. Target Y. Yes, target Y should be assigned by detecting the object. Yeah, the ROI box. Why did it not have a target Y available? That's weird. This is a fluke, I think. Let's try this again. Yeah, it was very crazy during the first Falcon Heavy launch, and like I said, I think that's why they're doing this now. And it's unfortunate, but I'm not terribly surprised. Whoa, okay. Yeah, that moves quick. Alright, so now we've got motion in both altitude and azimuth. So we have fixed the problem. And see there, oh, it centers up, it works nice, but it keeps going too far. And then it overcorrects. So it dances around. And the oscillations just get worse and worse. Okay, so stop joystick tracking, disconnect scope, stop camera. We're making progress. We're making progress. Love to get to the States and see a launch for myself. I bet every time you guys see one, it's like the first. So cool. It is really cool. And for years, it's something that I think a lot of us, myself included, took for granted during the shuttle program. After Columbia, when it became clear the program was coming to an end, that's when I stopped taking it for granted, and I wish I had made that realization a long time before that. But when it became clear the program wasn't going to continue forever, because it felt like it was, and you know, it hit me that we're not necessarily always going to be flying people into space in the U.S., and it seemed like that was going to be the end for a long time, and it has been. So the last shuttle mission flew in 2011, and it's going on 8 years now. This is the longest gap the U.S. has ever had without a manned a manned vehicle flying from U.S. soil since the dawn of Project Mercury, since Alan Shepard was the first American in space. We've always had manned programs, and there have been gaps. There was a gap between Apollo and Shuttle, but even that was not as long. Actually, I guess, yeah, Apollo Soyuz test project was the last manned launch from U.S. soil before Shuttle, but the gap between those two wasn't even as long as what we're now experiencing. So it'll be really nice to see people flying from Kennedy Space Center again. Seems like SpaceX is winning that race right now between SpaceX and Boeing with their manned crew capsules they're developing. And there's even talk of Falcon Heavy maybe providing propulsion for Orion EM-1 test to fly the Orion capsule around the moon. So there's a lot of interesting and active developments over there. I mean, it's crazy to think we went from, just having the space shuttle as our only access option to reach space. Now we're going to have Crew Dragon, we're going to have Boeing Starliner, and we're going to have the Orion capsule. I mean, that's 3 manned vehicles being developed here in the U.S. all at the same time. It's pretty crazy, and it's pretty exciting. So I hope we get those manned launches again soon, because not only will it be good to have that happening again off U.S. soil, but also it brings in a lot of tourism to those areas. Falcon Heavy brought in a ton of tourism to the area, and I think it's a good thing. I just hope that these changes they're making here, like closing down the roads, trying to make the traffic situation better, I guess. I hope it doesn't stifle the ability to come see these launches and landings. I mean, the landings especially, that's real special to be able to see those vehicles return from space and land vertically like that. It's amazing. It's like something out of a Heinlein novel. It's really super futuristic and sci-fi, and it is incredible every time we see it. Get to see it happen. So I hope they don't stifle that by closing 401 and all the rest. They really need to set up a park somewhere in Port Canaveral area. not just jetty park, but somewhere that's got a real clear line of sight to those landing pads. I just hope the people who are making these decisions have the foresight to see the need for that, but I kind of doubt it. So the search will continue for a new viewing site. Do I have a PID loop for this? Good question. Not really. I've got a loop. I wouldn't describe it as a PID loop. The telescope has an internal PID loop, and I'm basically fighting with it. I'm basically trying to trick it to do what I want it to do without having the ability to directly control it. And so I'm just looking at the output from that loop and trying to feed that back into the input to get what I want. In a nutshell. Alright, so let's come back up here. So we've got something that kind of works, but not really. I know I can make it work. I made it work in Visual Basic before, and we're just implementing it here in Python. But right now the implementation is not the full implementation of what I had going on before. Okay, so let's review this again. Right now, it looks at the frame time and says, okay, is this a new video frame? If it is, it gets all this information: current telescope altitude, azimuth, objects altitude and azimuth, and looks at whether it's further away or closer than it was before. If it's further away, it changes the correction factor. Okay, I think I see. Yeah, that's. I can kind of see why we're getting some oscillation here. One of the reasons, anyway. You've got this altitude and azimuth correction factor, which is only updating it if the distance between the target and where the telescope's pointed has increased from the previous frame. Otherwise, it stays the same. And so it's going to shoot past it, because of course it is. Because what we're doing is we're getting the, and this is ugly as a sin, converting this to radians, because I'm currently saving those degrees. Why am I doing this to myself? It's got that correction factor in there all the time. And it's not going to update that correction factor as it gets closer to the target. So the reason I did it like this was because this was meant to be, for the satellite tracking, this kind of works, but satellite's always moving, and we know where the satellite's supposed to be, and so you're just trying to lead the target. Here, the target might be moving, or it might not be moving. So there's multiple ways which we can improve this. One is we need to account for the motion of the object. We need to actually have the program remember a velocity vector for the object, which is not doing it all right now. It's just dumb, stupid, going to the latest altitude and azimuth that sees the object at. And really, if it loses sight of the object, we want it to remember the last known velocity vector and keep tracking based on that. Okay. So instead of just developing a correction factor here, which only updates if it sees the distance increasing from the target, we want something a little more intelligent. So, okay. One thing, instead of doing this, and this is ugly anyway, Okay, is there anywhere other than this? Let me just find all the instances where I use this. I'm going to convert this thing back to radians because this is stupid. Okay, it's using it there, where everything's been calculated in degrees. That's why I had it as degrees, I see. I see now why I did that. But then I'd convert it back to radians here and here. And then it goes into this stuff. And that's for equatorial. Okay, so one improvement would be to just turn all of this back into radians, at least at the end of it. I did it this way because I can think easier in degrees, and I wrote all these equations out assuming everything's in degrees. But at this step, it would make more sense to just convert these variables into radians, or just convert them into radians at the, convert them into radians here. You'd probably save processing overhead anyway, so object out equals math.radians. Object out diff in as equals math.radians. Diff in as. And now we kill this. Oops. Because we've already converted it into radians. Don't need to do it again. I even set up a, oh man, ugly. I even set up a whole new variable here just because I was converting it into radians there, and I just created a new variable to do that, which is stupid, but whatever. Kill this. Bring that over. Diff in as. All right. Diff. Where was this? Oh, that's for ASCOM. Okay. I'll leave that alone for now, but let's come back down here. So we convert that to radians, and then we don't have to deal with that again. What am I converting here? Object out. which I've already converted to radians, so this needs to go away. So I need to check the other one to make sure object out is not being double converted somewhere. Okay. Alright, so that's one issue solved. Just make things a little more streamlined. Oh, man, I did it again there. Okay. Okay. All right, so yeah, so this here is meant to lead the target by providing a correction factor that is constantly changing, but only when it sees the distance increasing, which is causing the oscillation. We can only assess whether we need to lead the target more or less when we actually see the target, which is why I've got it in the loop of where it has a new video frame. So that's all fine. But the way this sucker's working is not necessarily fine. And the way I had it before, in the original Visual Studio version, was that I set up a loop that would spend several iterations assessing what the correction factor should be, then updating the correction factor, and then go back to assessing what the correction factor should be. And so it would iterate back and forth, switch back and forth between what should the correction factor be, update the correction factor. What should the correction factor be, update the correction factor. It's not super efficient, but when you don't have direct control over the drive rates, it's kind of what you have to do. At least that's what I found you have to do. Maybe there's another solution out there, but let's go with that. So what I need to do is, when we're in joystick tracking, I need to reset and populate another variable. We'll call this iterations equals 0. Or, I don't know. Is this, yeah, no, that's, let's call I. I'm kind of worried I'm using that somewhere else probably. Iterate equals 0. Come down here. There we are. Okay, so if we have a new video frame, iterate equals plus equals 1. So that should, on every new video frame, it should iterate up 1. So first we need to figure out what the correction factor should be. We need to assess that. So it's going to spend several frames lagging behind the target initially, which is fine. And it's going to look at how much it's been lagging behind the target. And we're just going to do a straight averaging of how much it's lagged behind the target, to try to figure out how much we need to lead the target by in order to catch up to the target. So for, instead of this, we'll say if iterate is less than 10 frames. Alt correct equals whatever it equaled before plus the current diff, alt diff, and then as correct, same diff and as, same situation. Okay, else iterate, we will reset it to 0. Or no. We need to give it time to catch up. So L if iterate equals 10. When it equals 10, we will say alt correct equals alt correct divided by iterate as correct equals as correct divided by iterate to get the average. And then, so yeah, alt correct. But we need a different variable, don't we? It can't just be, no, it can't just be that. It's got to be something that is separate. Gulf City Milkman Dan. Sure, I suppose you could track a stolen UFO on a cosmic joyride. What it will give us ultimately, we're not there yet, but what it will give us ultimately are coordinates, right ascension and declination coordinates in hopefully IOD standardized format that you can load into existing software in order to calculate the orbit of the object. So right ascension and declination along with the time and location of the observation. That's why I still left, I'm not ready to execute the program yet. That's why I still left the latitude and longitude of the observer site in the program, even though you don't need that for tracking purposes. Since we're not tracking satellites or objects with a known trajectory, we don't have to know where we are to just do the tracking. We can just see where the object is in the video and do the tracking. But I still left those boxes in place because for the purposes of logging the observations, it might be useful to have those coordinates in place. I don't know if maybe I'll use like a roving observer format or something to save the observations. But basically, if you know where you are, you know when the observation occurred, and you know the coordinates, if you develop a table of those data, you can calculate what the orbit was and figure out where it was in space. So that's kind of the end goal with this, to be able to catalog unidentified objects traveling through the sky, things like classified satellites or whatnot. Should be able to calculate the orbits of them, even if they're not classified. If they're just something you don't know what it is, they're unidentified to you, you can figure out what it is by calculating the orbit. Okay, so if iterate equals 10, so we need let's do it like this. We'll call this correct running, as correct running, alt correct running. So these are going to be running numbers that are constantly being added up. This will be the average. And then when we're done with those, then alt correct running equals 0, as correct running equals 0. So we'll zero those values back out so that over the next 10 iterations, it will it'll start developing new correction factors. But we have to let the telescope catch up before we start before we start creating new running numbers here. We want to let the PID of the telescope do its thing and catch up to whatever it is that we're tracking. So we are not going to zero out the iterate number yet. If iterate is greater than, say, let's give it another 20 frames or so, then we'll zero that out. Or iterature, yeah, that's good. Iterate equals 0. All right, I'll be right back. Hang on a second. Alright, sorry about that. I'm back now. Alright, see you, Moo Moo. Thanks for coming. Alright, let's see here. We're almost at a point where we can start really testing this thing here. Oh, what the heck? Oh, that's weird. I don't know if it did that on the stream just now, but I just had this weird thing where it blinked at my screen and came back. Okay, so we're going to give the program about 20 frames to actually execute the correction factor and see how well it's fixed it, and then it'll start correcting again. So we got the correction factors. That will only really be able to it'll only be able to learn what the correction factor should be if it actually sees the object, right? We could pull... It's kind of complicated, but we could pull this out. We probably should. Yeah, let's do that. This out of the if we have a new frame thing. I don't know, maybe not. Maybe not, maybe not. I'm thinking we could pull half of this out of the loop that checks if we have a new frame and iterate outside of that so that we're still no, I don't want to do that. I don't want to do that. The other thing, see, this is the that's the other conundrum. Is the yeah, it needs to remember what the previous correction factor was. That needs to be a function of it. That needs to be part of it. And it's not at the moment. It's going to regenerate that correction factor fresh each time at the moment, which is not really what we want. So what we can do is alt correct running will be initialized with alt correct. As correct running, same thing. Let's see. Will this do what I want? Let's think about this. So it's going to be initialized with those values, and then we're going to add on to it whatever the difference is. I think that's kind of what we want. Okay, so and in that case we don't need to zero them out because we're just going to reinitialize them. But the problem here, okay, there's still an issue here. This isn't really going to work the way I want. The issue here is, okay, let's say that the alt correct completely fixes it and it's perfectly centered. It's going to see, okay, alt correct running is the initialized value, and the alt diff is going to be 0, 0, 0. Then it's going to divide it by 10, and now we're going to have a value that's 10 times too small. So maybe we need to initialize it times, well, actually this would be iteration, initial iteration is going to be what, 0? But it's going to go to 1 right away. So it should be times 9. because it step 10, it's not going to do this, so it's going to be 9 steps really. It's really 9 frames, not 10. Yeah, I think that'll work. We'll try it. Okay, so there's that. So we got the correction factor now. Let's assume that this is taken care of. This is okay. Even if we're not updating the correction factor because we can't see the object, we need to update the object's current altitude and azimuth based on its last known velocity vector, which we need to calculate. And we can potentially do that so okay, last step before we close out the loop, the loop here, we need to save. We need to save it for the next loop. Actually, yeah, there's a little complication here. We want to remember where the object had been last time. We can actually pull this up. We need to dump it into, because this is something that's going to be empirically determined by seeing the video. Oh, that got thrown in there somehow. That's not good. So this needs to go in here. So it remembers what the object as last and out last was. And we need to initialize these values. We'll initialize them based on the pointing from the telescope during the joystick tracking. Object follow. Okay, so as last is going to be current as, out last is going to be current out. Okay, those are going to be the initial values. And then when we come down here, so we'll remember where the object had been the last time it was seen. And before we do that, we will calculate the altitude and azimuth rates of the object, which is going to be, this is all going to be in radians, right? Yes. Okay. So object out rate will equal as rate will equal object as minus object as last. So it'll be a bit noisy here because we're not averaging these values. We're not putting any kind of filter on these values. They're just straight values from whatever was seen last. But for a starting point, this will work hopefully. And this is going to be, we need to actually take into account the amount of time that's here, right? So that's going to be the difference between D now, self D now, and self D last. So it's this many degrees per whatever this is. So, oops. Now, what did I do? Okay. Okay, let's put this in parentheses. I don't know if it's going to let me do this. I'm working here with time objects and the same thing as floating point objects. I don't think that's gonna. I don't think it's gonna let me do this, but I'm gonna try. I wonder if I can treat this as a. I don't know. That might not be ideal. I'm sure this thing's gonna spit errors at me, but we'll fix them as we go. Okay, so this will give us the rate in hopefully degrees per whatever time units here. So when it comes time to actually track the object, we'll have the correction factor, we'll also have the azimuth and altitude of the object. We also need then to look at the current time from self-D now to actually right now. Self-D now is assigned where? That is assigned here, date, time now. So here's where self-D now is actually assigned. Well, it's assigned when you first click, but also later on when it gets images. Self-collect images is true. When it gets a new image, it says, okay, date, time now. So that's when it actually got the image. But now we need to calculate when now is, when it's actually doing these calculations on the images. So, where are we? Okay. So we need to say, okay, decalculate equals date, time now. And so now we say, okay, the azimuth should be, and we need to also figure out how much time has elapsed. So that's going to be elapsed time equals, and this doesn't need to be a self object. It's going to be decalculate minus self D now for the latest frame. So that's going to equal object as plus object as rate times elapsed time. This is going to equal object out plus object out rate times elapsed time. And again, I expect we'll probably encounter some errors here because I don't think I've done this quite right, but it's a start. Alright, let's see what happens. If iterate. Oh, equals 10. Okay, there's one problem. That's a beginner problem right there. That should be equals equals. Okay. Well, it's happy so far, but it may not be happy with me in a minute. Okay. It did that thing again where it says buttons object has no attribute target Y. Huh. Okay. Failed to do the math, and then it said object aspirate reference before assignment. Okay, there was another potential problem. Okay, I think stop, disconnect, stop camera. Okay, we got a little issue here. Let's take out this exception here. Actually, no. Let's do a trace back on that. How do we do that? Let's see. Okay, there we go. Trace back. That's what it is. It's I guess the simple way, just take this out for a second. Alright. Okay, let's try this again. Let's just see what errors it's giving me. I'm sure it's not happy the way I'm working with those date time objects. What's this error say? Incorrect running altdiff. Incorrect running reference before assignment. Okay. That's that issue. Okay. I didn't think about that, but okay, so oops. Back up here we need to correct running needs to be, this needs to be correct running instead of just correct. Okay. Float and date time delta. It doesn't like that. Okay. I figured it wouldn't like that. Okay, so maybe one way of solving that would be to treat this as a float. I don't know. Let's see if it likes that better. And then down here, treat this as a float. Let's see if it likes that better. Says again, target Y doesn't exist. Why not? It should. Okay. Float argument must be a string or not. Okay, I can't force that to be a float is the issue. I don't know why it thinks that there's some sort of out of sync issue, I think, where it doesn't see the target Y. It just starts straight into it somehow. I'll fix that later, but okay, so I can't force that to be a float. Time delta to float. Total seconds. Oh, okay. Okay. So this instead of doing this as trying to force it to be a float, that's not going to work. But I can do this as total seconds. I don't know if it's going to work right doing it that way, but maybe. Let's see. It's probably not going to work right doing it this way. But it did. Whoa, 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 whoa. What are you doing? Okay, it's sending it the wrong way in azimuth. Or something. Okay, the commanded as is getting progressively worse there. We're making progress though. Maybe. Okay. Let's close out of that. I wonder if it's got something to do. Let me try this again. I wonder if it's got something to do with the azimuth coming back around to 0 or something. I don't know. Azimuth 15, altitude 15. Yeah, okay. Nope. Target log, whatever. Commanded as keeps going up. Math domain error, yeah. Divide by 0 or something along those lines. Math domain error. Yeah, if you get to very small values of the difference, it tends to crash. Okay, that's very interesting. Let's see here. All right. So it runs away in azimuth. It constantly increases the commanded azimuth. Okay, I'm not as concerned about this at the moment. I mean, it knows the distance from target is increasing. It sees that. And it's giving a higher and higher commanded azimuth. But somewhere in the middle it's messing up. Let me comment out these two lines. I really want to see what's going on with what it thinks the as rate is. If it thinks that's constantly increasing or something. Let's try this. Just want to see what's going on here. Okay, now let's click. No target Y. Huh. No. Let's try something else here. And it's like the further away it is, the faster it moves. But only to the right. It's kind of strange. Okay, in addition to the as rate, let's see what it thinks the object's azimuth actually is. let's put this into degrees. Make sure that's all good. Close that off. Okay, let's try this. Just, oops. Where did I put the window? Oh. Okay. Just trying to diagnose the problem still here. Okay. It thinks the object's azimuth is going the wrong direction. Right. Okay, the object's azimuth is the wrong direction. Okay. Alright, fine, fine. So what does it think if I go the other way? If I tell the object is to the right, that's really strange. It sees it to the right. But if it's to the left, it also thinks it's to the right. Okay. What could cause that? Commanded azimuth is 19.6. Okay. Alright, that's definitely the problem. I just don't know why it's happening. Alright, stop that, disconnect, stop. Okay. Close. Alright, so the problem is definitely that it thinks the object's azimuth is something it's not. Something to do with diff and as is math radians, diff and as. Diff and as degrees. If anyone in the chat has any suggestions, call them out. Object out, object out. Current as plus diff and as. Current as is in radians. Okay, that's all in radians. So it's not a problem with the radians. Something goofy about this. Not calculating the correct azimuth for the object. It's weird. Why? I mean, These equations worked fine for Sat Tracker. It's not doing anything to it after this point, is it? No. Okay, let me try something here. I want to test and see. Does it get it right if it's to the right? Oops. No. Yeah, that's not going to work like I thought. Thought it was way over 24. Thinks it's at 34. It's not. Yeah, that's peculiar. Let's come over here. Huh. Huh. Hmm. I don't know. Diff and as is an absolute value. That's what it is. That's what it is. Dang. Alright. I understand the problem at least. So, it's calculating difference in azimuth, but it's calculating an absolute value. So I need to assess object angle. Okay. Let's see here. Need to assess object angle and make a determination based on that. So we have object angle 2. One is minus 90. Let's get object angle in here. Let's see what object angle is putting out as. Because it always thinks it's to the right. It always thinks it's a higher azimuth than the current azimuth, even if it's a lower azimuth than the current azimuth. So, let's see. Let's come back over. Object angle is negative 100. Object angle is 72. Object angle is negative 232. 90. 80. Negative 230. So it goes from about negative 270, jumps to 90. Okay. Negative 90. Negative 180 is directly below, and I'm guessing this is, yeah, that's 0 degrees straight up. Negative. So it goes from 0 to negative 180. So from 0 to negative 180, object angle. Then diff in as needs to be positive from 0 to negative 180. From negative 180 all the way back to 0, for basically any other value, object azimuth should be negative. Okay. Solution found. Solution found. So object angle. If object angle is what? Between, so it's less than 0 and object angle is greater than negative 180, then this. Else this needs to be subtracted. Boom. Done. Alright, let's see if this works. Scope, start joystick. Well, would you look at that? Map domain error. Fine. Okay. That correction factor takes a long time to catch up. It does eventually catch up, but it's not as snappy as I'd like. But we can fix that. The other issue is that whole deal where it thinks, sometimes it thinks that the target Y hasn't been assigned. It basically doesn't see these coordinates existing yet sometimes when you click. So it's like they need to be populated when you click, which it should have been. I don't know why it wasn't. So hi work. Yeah, we're just working on object tracking here. Start X. See here, I've gone ahead and assigned start X, start Y as those values at the start there. And that's if object follows true. And it should be assigned here too. Oh wait, but it's assigning it the other way around. What am I saying? Okay. Well, let's find. So that is there. If object follow is true. It should be assigning it based on the ROI box, but it's like it hasn't had a chance yet. Because this is under... yeah, it hasn't had a chance yet. It hasn't collected a new frame yet. Okay. So okay, so here here's where I handle left click events. So I need to set ROI height, ROI width, ROI shape, ROI box, mouse box, ROI box last, ROI box. So up here I need to set target X, target Y. I need to set those up here under the left click event. That's what that is. There. That should take care of that problem. Except I haven't defined ROI width yet. You just pull that up from there too. Okay. ROI height, ROI width. Okay, so setting that there so that as soon as it gets a left click event, it sets the target X, target Y so that the program's not left hanging, because there's the potential randomly when you click left to designate a target, if it hasn't pulled down a new frame yet by the time it gets to all this stuff here, or actually down here, if it hasn't assigned, if it hasn't pulled a new frame yet, by the time it gets to all this stuff, it's going to generate an error. So, okay. Now we can catch for math domain errors. So that should be the only error left. Do that. Alright, let's see. Oh, actually, close it. I also want to change how many frames we're running here. Let's do 5 frames here. Let's do 6 frames. If it equals 6, then we do this. And then we do this. And let's say here, if it's greater than 15 frames, we'll make it kind of twice as fast, this whole loop of finding the correction factor. Alright. Connect scope. Start joystick tracking. And catches up eventually. It's getting there. It's getting there. See if we can make it a little more responsive. It's less than 4. If it equals 4, we do this. And we're just doing an average of 3 frames now for the correction factor. And if it's greater than, say, 7, and instead of printing object as now, let's print correct as correct. Do math degrees on that too. Okay. All right. Oops. Ah, messed up my window size. Oh no. I've gone and goofed things up, haven't I? Okay. I'm not sure why it does that, but let's try this again. Note to self, don't resize window before starting camera. Decanter does not like that. Okay, scope, start joystick tracking. Settles in. Let's just check camera calibration again. Stop joystick tracking. Let's do camera calibration one more time to make sure things are calibrated correctly. Okay, scale. Okay, I think there's one more improvement I can make here pretty easily. And that's to reverse the order of some things, maybe. Or, at the very least, yeah, kind of. Okay. So, if it's, let's say if it's greater than, I don't know, 15 and less than, iterate, is less than 20. If it's equal to 20, then we average them. And instead of divided by iterate, it's actually now going to be, so it's 16, 17, 18, 19, so 4. 4. 4 frames. We'll just divide by 4. And if it's greater than 20, then we reinitialize outcorrect running and set error rate back to 0, and then monitor for a new outcorrect running. But we don't monitor until we hit frame 15. So that gives it plenty of time to correct under the previous correction. It also gives initially acquired objects time, because if an object's not moving, you don't want a correction factor. You're overshooting every single time. So hopefully this will help fix some of the overshoot. Yes, yes, that's much, much better. Okay, let's tune that up a little bit. So I'm not even using the joystick at this point. This is all tracking with just clicking with the mouse. So let's say if it's greater than 10, less than 15. If it's equal to 15, we do the average. If it's greater than 15, on the next step, we reinitialize outcorrect running, set error rate back to 0. Still overshoots a little bit, but it gets it. It gets it eventually. Okay, cool. Now, let me go grab my laser pointer and we'll have some fun. in lieu of a laser pointer, I will just use a flashlight. So let me make sure I'm zoomed out all the way on this camera. There we go. Okay, now let's recalibrate the image scale. Oops, stop joystick tracking first. Okay, now it's going to recalibrate. And as soon as that's done, we'll see if we can get it to chase a flashlight across the wall here. So exciting stuff, guys. We've made some serious progress here, and now the basic functionality of my UFO tracker is working again with the LX200. Alright. Now let's do tracking type brightness-based tracking. I didn't want to go there. What's going on? Unable to track that frame. Really? You can't track that frame? Iterate reference before assignment. Why does it think iterate was used before assignment? We got a bug here where you have to do joystick tracking first, maybe? Yeah. Well, I'll fix that in a second, but whoa. No, not that direction. Come back down. I'm just doing brightness-based tracking, so you need bright light, like sunlight hitting the ceiling. It's going to try to track that. So, should continue to track at last known rate, which it kind of does. But, as it approaches the horizon, I think it's going to stop trying to follow it. So it tries to contract at the last known rate if it loses sight of it. That's good. Alright. One more bug to fix where it doesn't populate iterate properly. Because if I tell it right off the bat, okay, I go track that, and then I do brightness-based tracking. So this, yeah, local variable iterate has not been assigned. I'm sure I made a simple mistake there somewhere. Let's fix that. Exit save configuration. Alright, so iterate plus equals 1. So iterate should have been set to equal 0, but it skips, there's the problem. It skips this step. Okay, we're going to move this out because it skips this step if you're going straight to object tracking on video and not using the joystick. It's going to skip that step. So we'll set it up here so that when we initialize the program, it will set base variable as 0 there. Okay, now it should theoretically work. No. Object as rate reference before assignment. Okay. Disconnect scope, stop camera. Okay, object as rate. So the rates, yeah, need to be initialized as well. As rate object. Object as rate equals 0. Object out rate. 0. So if we haven't tracked them with the joystick at all yet, we'll just assume they're not moving at the initial step. Cool, we've done it. Alright. Exit and save configuration. That's it. Alright, we've got the basic version working. So I'm going to continue working on this, implementing basically everything we just did, just copying it and replacing some of the altitude and azimuth coordinates with right ascension declination, but it's much the same. It's just a different coordinate system for when the telescope is polar aligned. Also, I'll be working on implementing coordinate logging of the current coordinates of the object so that you can calculate the orbit based on the observational data. Alright, thanks for watching, folks. That's going to do it for this stream. Stay tuned in the near future for some nighttime object tracking using this program. Thanks for watching. Clear skies, folks.